All right, so reducing ratios and solving proportions. So first thing we need to do is a little bit of vocabulary. So the definition of a ratio is a fraction that compares two different quantities. So it's a fraction that compares two different quantities. So some examples of ratios would be if you say 2 shirts per or over $6, or 3-foot side for a 2-foot base. Those are fractions that compare two different quantities. You'll notice that on the first one, the units are different, shirts over dollars, and the second one, the units are the same. That makes a difference in the kind of math you can do with it, so we'll go over that later. But the main thing is when you're reading a ratio, the fraction bar is interpreted as per or for, most typically. So like 2 shirts for $6, 3 feet per 2 feet. If 2 pairs of objects reduce to the same ratio, but start with different quantities, they are called similar objects. So an example of that, let's say you've got $4 per 12 cans versus $1 per 3 cans. So we have 2 pairs of objects that start differently. One's $4, the other one's $1. And then we end up reducing those. And when you reduce the fractions, on the left, you get $1 for 3 cans. And on the right, you keep it the same because it's reduced already, $1 per 3 cans. And when you reduce it, it actually ends up being the same. So those would be called similar quantities or similar objects. Okay, part B, steps for reducing ratios. Number 1, you're going to prime factor the top and the bottom. Number 2, you're going to divide any equal factors to 1. Number 3, you're going to re-multiply the remaining factors. And number 4, the last thing you're going to do is simplify the signs. Trick about fractions is we get so used to doing mental division that when mental division doesn't work, oftentimes we're dead in the water. We don't know how to reduce the fraction. So I'm trying to give you a method that you can reduce any fraction, no matter how complicated or how many variables are in it. You have at least a strategy to attack it with. I fully understand that if it's something really easy, like 3 over 12, you're going to know that reduces to 1/4. But what if it's 96 over 12? How do you reduce that fraction without guessing? So the way I'm showing you is how you reduce the weird ones, the big ones, the strange ones, the ones with letters. But to teach it to you, I'm going to start really simple. So these I realize you could actually reduce without a special technique, but we start easy while we're learning. Okay, so the first fraction is 5x over 10x squared. So step 1 is prime factor the top and the bottom. Well, 5 is prime and x is prime, so that's really easy. And then on the bottom, 10 factors into 2 times 5, and then it has an x squared, which is x times x. Prime factoring means reducing the number to prime numbers. Okay, that's step 1. Step 2, divide any equal factors to 1. So 5 goes into 5 one time, x goes into x one time. And that's all that we can divide. Step 3, remultiply the remaining factors. So on the top, I have 1 times 1. On the bottom, I have 2 times x. So I get 1 over 2x. Dividing to 1 is a way to prevent you from accidentally flipping the fraction. I mean, that's where people get like 4 over 8 equals 2. When it doesn't, it equals 1 over 2. It equals a half. So dividing to 1 kind of fixes that issue. Okay, let's do another one. 12 obviously does not go into 28. So we're going to prime factor. The 28 is negative, so -1. And then now here's how, if you can't do it in one step, you can do it in 2. So let's say that you only know that 28 is 4 times 7. And then I've got a g cubed. So you're going to stop there. And then on a second step, you're going to finish it. So -1 is prime. 4 is 2 times 2. Then I have a 7. And then I have 3 g's. So you can actually break numbers down as long as you can think of any 2 numbers that multiply to give you that number. You can then go one more step to primes. Okay, same thing with 12. 12 is 6 times 2, and then I have a g squared. And then going clear to primes, 6 is 3 times 2. The 2 that's already there is prime, and then g and g. So if you need to take 2 steps to do it, take 2 steps to do it. All right, so I can divide a 2, another 2, a g, and a g. And what do I have left? A -1 times 7, which is -7. I have a single g left over 3. All right, let's do example 3. 42 and 16. Again, these are the ones that most people don't do well in their heads. So it's a -42, so the negative is a -1. And then I'm going to do this one in one step just to show you how you would think about it. 42 is 6 times 7. 6 is 2 times 3, and then times 7. So if you can keep the numbers in your head, you can break them down as you go. And then I have 4 n's, 1, 2, 3, 4, over -16, which is a -1. 16 is 4 times 4. So the first 4 is 2, 2. The second 4 is 2, 2. And I have 6 n's. 1, 2, 3, 4, 5, 6. 6 n's. All right, remember in Algebra 1 when they said, hey, a negative divided by a negative is a positive? And you're like, okay. Did they ever tell you why a negative divided by a negative is a positive? I know they didn't tell me. The reason a negative divided by a negative is a positive is that a negative is actually a -1. And if you have a -1 on top and a -1 on bottom, how many times does -1 go into -1? 1 time. No more negative. That's a +1. That's why a negative divided by a negative is a positive, because they divide in 1 time. All right, here we go. Divide out a 2. That's pretty much it. An n, an n, an n, and an n. That's all I've got left. So on the top, 7 times 3 is 21. On the bottom, I have 2, 2, 2, which is 8, and n, so n squared. All right, I want you to go ahead and do example 4 on your own. Go ahead and prime factor and reduce it. Okay, so let's go over this. And I see some of you did it in one step, some of you did it in two. It's fine if you do it in one, it's fine if you do it in two. So 8 is 4 times 2. 4 is 2 times 2 times 2. So 8 is 2, 2, 2. Then I have 3 x's. On the bottom, I have a negative 1. 40 is 4 times 10. So 2 times 2 is 4. 2 times 5 is 10. And then I have x, x, and x. So now it's prime factored. Divide out a 2, and a 2. Divide out an x, and an x. Everything on top divided to 1. On the bottom, I have a negative 1 times 5, which is a negative 5. Numbers will never switch from top to bottom when you're simplifying a fraction. If the 5 is on the bottom, it's got to stay on the bottom. Now, here's another rule. Let's write this at the bottom. When you simplify, there can be no negative monomials on the bottom. No negative monomials on the bottom. If there is one, you're going to simplify it up. So that's where you can use your division rules. A positive divided by a negative is a negative. The negative then goes up with the 1, and the 5 stays positive. So even if you have a scalar, even if you have a scalar, you still can't have a negative scalar on the bottom. You got to get that out of there. Okay, so flip the page. I want you to flip past the practice. We'll go back over that at the end if we need to, but let's go to the solving proportions part. All right, solving proportions. First of all, what is a proportion? A proportion is an equation stating that 2 ratios are equal. 2 ratios are equal. So an example of a proportion would be 2 pounds over 3 square inches equal to 4 pounds over 6 square inches. So in other words, a proportion is an equation with an equal sign. A ratio is just a fraction. A proportion has an equal sign. When you have a proportion, the top quantities are matching. In the case of our example, it's pounds on the left, pounds on the right. The bottom quantities are also matching. In our example, 6 square inches and 3 square inches and 6 square inches. They're both square inches. So both fractions, actually, if you were to take them separately, both fractions reduce to the same number. And you can tell this is true because if I pull the numbers off, I've got 2/3 equals 4/6. 4 is 2 times 2. 6 is 2 times 3. And I get 2/3 equals 2/3. So the units are the same, the numbers look different, but they actually reduce to the same thing. Those are all qualities of a proportion. Okay, steps for solving a proportion. You're going to use a lot of reciprocals. Use reciprocals to get x on the top of the fraction. And then you're going to use reciprocals again to eliminate the bottoms from both sides. Typically when people have trouble with solving proportions, it's because they never learned to do it with reciprocals. Whereas there's the easy stuff and then there's stuff where you have to use reciprocals. So to solve for x, simplify both sides, add or subtract x terms left and number terms right, multiply by the reciprocal to get a 1x equals an answer. Okay, flip the page. Now, there are more than one way to solve these. I'm going to show you one way to do it. If you like it or you don't have another method, then do it the way I'm showing you. If you have another method that works well, use it as long as it's working for you. So on example 1, we're trying to solve for x. So to get rid of the bottoms, the easiest way to do it is to get a common denominator and then to eliminate it. So 14 and 5 don't have anything in common. So to make them the same, I'm going to multiply the left fraction by 5 over 5 and the right fraction by 14 over 14. When the bottoms match, in other words, they both have a 5 and a 14, then you can eliminate it. And the way you eliminate it is by multiplying by the reciprocal over 1. So the reciprocal would be 5 times 14 over 1. And of course, if you do it on the right, you got to do it on the left. 5 times 14 over 1. And what this does is when you have a 5 on top and a 5 on bottom, just like reducing fractions, they cancel out. Notice I'm not worried about multiplying the 5 and the 14 together. Why? I'm just going to cancel them anyway. So just leave them fractional. So now what I've got is 5 times 3x equals x minus 2 times 14, and I have no more fraction. All right, so to solve for x, we need to simplify. So I'm going to backwards distribute the 14. That gives me 14x minus 28. And then 5 times 3 is 15x. So this is basic algebra 1 solving. So we're going to subtract 14x over to the left, and we get x equals negative 28. You might have known that technique as clearing fractions, getting a common denominator and clearing fractions when you solve. Now, this will also work if you have a binomial on the bottom, like number 3 down here. The same thing will work. First of all, the negative that's in front of the 3/4 is not really in front. There's top, there's bottom, there's numerator, there's denominator, there's no sideinator. It doesn't exist. So that negative is actually on top with the 3. So the first thing you probably want to do is just move it up to the 3 so it doesn't get lost when it's not where it belongs. Okay, so we're going to do the same thing we did with example 1. We're going to make the bottoms match. So on the left, I need an x minus 16. So I'm going to multiply by x minus 16 over itself. On the right, I need a 4. So I'm going to multiply by 4 over 4. Now on your work, I fully assume you're just going to cross off the bottoms and go, but these are notes. So the reason you can cross off the bottoms is we're going to multiply both sides by the reciprocal, 4 times x minus 16 over 1. And that's why you're allowed to cancel out the bottoms. So now we've got x minus 16 times negative 3 equals x plus 1 times 4. And then now we're going to solve. So you're going to backwards distribute the negative 3. So I get negative 3x plus 48. We're going to backwards distribute the 4. I get 4x plus 4. And then I'm going to skip a few steps. You subtract 4 over to the left and you get negative 7x. You subtract 48 over to the right, you get negative 44. Now, here's maybe a different way of looking at this. To get rid of the negative 7 off of the x, try a reciprocal, which is 1 over negative 7. You say, well, why? I can just draw a line and cross it off. That's because when you have fractions or weird terms, you can't just draw a line and cross them off. It doesn't actually work. So you need to know how to do this so that you are able to handle weirder ones. So x equals 44 over 7 when you're done. Okay, so that's how you get rid of an x in the denominator. So let's go to example 2. This is different because we have 2 x's, x on the left and x on the right. So I'm going to show you a shortcut. It's a very good shortcut. If you have a fraction equaling a fraction, you can actually flip the left fraction and the right fraction. My students termed it Flippy step because we needed something to call it. So on this one, since the x's are both on the bottom, I would probably just flip both sides. And that would give me x plus 1 over 3 equals x over 2. That moves the x's up in one step instead of 3 steps. All right, so now getting rid of the 3 and the 2, get a common denominator. So multiply this one by 3 over 3 and the left by 2 over 2. I'm going to use the shortcut. Once you have a common denominator, you multiply both sides by 2 times 3. They cancel out. And you have 2 times x plus 1 equals 3x. So common denominator and eliminate. Just put dot, dot, dot. When you solve this, you get x equals 2. Okay, example 4. This one also has an x on the bottom and no x's on the top. So again, you could use Flippy step. So flip both sides, you get 2 over 9 equals negative x over 11. Okay, to get the 11 away from the x, get a common denominator. So I'm going to multiply the right by 9 over 9. I'm going to multiply the left by 11 over 11. When the bottoms match, you can divide the bottoms out. And that leaves me with 22 equals negative 9x. To get the negative 9 off of the x, multiply by 1 over negative 9 so that the 9's cancel. And I get x equals negative 22 over 9. Okay, so we're going to practice. We're not going to do the whole problem, though. We're just going to do part of it. On number 1, I want you to go ahead and get rid of the denominators. I want you to clear the fractions. Go ahead and do that. Just clear the fractions, and then you can stop there. Okay, so to clear the fractions, they got to have the same denominator. So I'm going to multiply the left one by 6 over 6 and the right one by 3 over 3. When they both have a 6 and a 3 on the bottoms divide out, and I get 6x equals x minus 2 times 3. Cleared fractions. Okay, just put a dot, dot, dot. This one solves to be x equals negative 2. We're not going to take time with the algebra 1 solving. Okay, I want you to go to number 3 now. I want you to clear the denominators. Clear the fractions on number 3. All right, so on number 3, this one has a 4, that one has a 4x. They both have a 4 already. So really, just this one needs an x. So multiply by x over x. And now you have 3x equals negative 3x plus 2. and you solve, you end up with x equals 1/3 when you're done. All right, go to number 2. I want you to use Flippy's step to get the x's to the tops of the fractions. Go ahead and do that. Do Flippy step. Okay, so sometimes what I see is people really like this common denominator thing. So some of you, I can tell, did exactly what we did on 1 and 3. You got a common denominator and you eliminated it. Perfectly fine. That will work just fine. So let me show you that first, and then I'll show you the Flippy step. So yes, you can actually get a common denominator. So multiply this by x plus 5 over x plus 5. Multiply this one by x minus 1 over x minus 1. When the bottoms match, eliminate, and you have x plus 5 equals negative 3 times x minus 1. And that is perfectly legit. Fast way to do it. Using Flippy step. Flippy step is great for when your x's are in the bottom only. There's none in the top. So you just flip both sides. So that gives you x minus 1 over 1 equals x plus 5 over negative 3. Then you're in a position to get a common denominator and eliminate the fractions. Both techniques work. All right, let's do the last one. You can do this one using Flippy step or common denominator, your choice. All right, so Flippy step, flip both sides, you get 7x over 8 equals 3 over 16, and then you can clear fractions. You don't have to clear fractions though. If you just want to get the 7/8 away from the x, use the reciprocal, which is 8 over 7. The 8 over 7 cancels the entire fraction out, and you end up with 3 times 8 over 16 times 7. So to get a fraction off of an x, use the reciprocal. And then, of course, this one, I know that 16 is 2 times 8. So I'm just going to factor 16 into 2 times 8, take out the 8s. X equals 3 over 14. Okay, so any questions?